Before leaving the subject of arrays and loops, I want to mention multidimensional arrays. Now these are in effect arrays of arrays. In C you're not restricted to storing arrays that extend in single rows, as I've done up to now from 0 to some upper limit. You can also have arrays that have both rows and columns, a bit like a spreadsheet. One dimension stores the rows and the other dimension stores the columns. And you can see an example of that here, where I have these numbers in rows and these numbers in columns. In fact, you can also have arrays that have more than 2 dimensions. But I'm going to leave that to one side for now. It's the same way that you would declare them. You just add more dimensions in the declaration up here, and you would put arrays nested in arrays. But conceptually, it's easier to work with 2 dimensions. So that's what I'm going to stick with. Now you'll find this in the 03_multidimension arrays project, so if you want to follow along with the code, that's the one you'll need to load. Just as with single dimensional arrays, I can initialize the elements of a multidimensional array by putting each element between curly brackets and assigning them to the array variable at the time of its declaration. Now in this case you can see that I've got an array element, an array variable called grid, and I've initialized it by putting these sets of curly brackets inside another set of curly brackets. So the inner sets of curly brackets are the nested arrays, if you like, that are contained in this outer set of curly brackets. Now here I've got the array variable grid that contains 3 arrays of 5 integers. So going back to my spreadsheet analogy, think of this as a matrix, like the matrix of a spreadsheet, with 3 rows and 5 columns. And if this were a spreadsheet, the intersection of each row and column would form a cell, and the contents of each cell would be an integer, 1, 2, 3, 4, and so on. To access a specific piece of data, that's the contents of each cell, I need to give its cell location using square bracket notation, with the row index in one pair of brackets and the column index in another pair of brackets. So this is how I would print out the value stored at row 1 and column 2. Remember that arrays begin at index 0, so this gives the item on the second row in the third column, namely the integer 8. If you want to iterate over these arrays, you'll need to iterate first over the rows. That's the rows of nested arrays. For example, I can do this using a for loop like this. And now the for loop initializes the row variable. It could be called anything, but I've called it row just to use the analogy of the spreadsheet. It initializes the row variable to the index of one of the nested arrays on each turn through the loop. And in order to iterate over the items stored in each nested array, which I'm going to think of as columns of my grid, I need another for loop inside the first for loop, like this. So here my sample code just iterates over all the items stored in my grid 2-dimensional array, and it displays the row number followed by the column numbers and the data, that is the int, stored at each location. So let me run it so you can see how this works. And here you can see that that's exactly what it does. It displays the row, first starting with row 0. This is done in the outer loop. And then the inner loop iterates through the items, that is column 0, item 0 if you like, in the row array. And that returns the value there, which is 1, then item 1. I'm calling it the column, thinking of it as a spreadsheet, and it gets the value 2, and so on. Now, you might wonder what you would do if you wanted to break out of the inner for loop. I've spoken before about how to break out of loops, but here I've got 2 loops. So what would happen if I try to break out of the inner loop? Would it exit the outer loop too, or would it just exit the inner loop? Well, let me try this out. I'm going to put in a little break condition here. If column, remember column is the iterator on the inner loop. If column equals 2, then I'll break. So, let's see what happens when I run it. And these are the results. So from this, you can see that the inner loop breaks when, in this case, row is 0 and column is 2, but the outer loop continues running. And that's why it breaks again when it comes to row 1 and again column equals 2. So this shows that break causes an exit from the innermost loop only. Now, once again, I want to emphasize here that breaking in this way is very often not the most elegant way of terminating a loop. And whenever possible, you should try to terminate a loop only when the loop condition is met. For example, when the test in a while loop or the expression in the second part of a for loop, here for example, when column is less than 5, execute the loop until that condition is no longer true. So if you try to exit the loop when the loop test condition evaluates to false, your code will be much clearer than if you make a habit of breaking out by scattering these break statements through your code. There are times when breaking is useful, but for the clarity of your code and the maintainability of your code, it's best if you don't make a habit of breaking when you can exit a loop using a clear test condition.